Okay, students, let's chart the in concrete technology. The chapter 3 is the properties of concrete. This is a very most important chapter. So to determine the properties, that means the workability of the concrete and properties of each and every individual ingredients which are used in the concrete. Let's go to the introduction. Okay, students, let's start the chapter 3, that is properties of concrete. This is very much important chapter to determine the properties of various concrete ingredients and also the workability, durability of the concrete. Introduction. First is the, what do you mean by the fresh concrete? So this is a common general, the basics things. The fresh concrete in the sense, as soon as we mix the concrete ingredients, that is called cement, sand, jelly, along with the water. Once we mixed all together, we will get a concrete, but it is a freshly mixed. That means as soon as it has to be mixed, it is ready for pouring into the any structure. This concrete is called it as a fresh concrete. Then what do you mean by the green concrete? See, green concrete is nothing but, see, as soon as the fresh concrete has been mixed due to some interval, so what happened? The concrete is become a stiff, but still it is in a workable state. So that kind of concrete is called as a green concrete. This concrete is also called as a wet concrete or else plastic concrete. That means the concrete is already got a stiffness. That means the setting has been started, but still we can work into it. That means we can make it into the suitable shape and size. Then what is the main objectives of these properties of concrete? Okay, why we have to study these concrete properties? First is to maintain the workability of the concrete. Definitely. The concrete to determine the workability in the sense so that any concrete we can easily place and we can easily compact and we can easily apply the vibrator so that it can mold into the any suitable shape and size. So that is the workability of the concrete. To maintain the workability, so you have to study the properties of the concrete. To design a proportionate mix to obtain the desired strength, of course, to decide the proportion of ingredients that has to be used, like the cement content, what is the proportion of sand and what is the proportion of coarse aggregate, that we need to design it to obtain the minimum strength and durability. To make the concrete is impermeable. Yes, of course, the concrete is always impermeable in nature. It should not allow the water to flow inside into it. Okay, then to choose the correct water cement ratio for obtaining the desired strength, definitely the selecting the water cement ratio plays a vital role in the strength of the concrete. Then what are the properties of fresh concrete? Of course, the properties of fresh concrete is it can be easily mixed and we can easily transport it to the site place. And the fresh concrete should be of about a uniform throughout the given batch. That means even if it is a 2-3 batches of concrete, so the concrete proportions and the ingredients mixed together should have a uniform throughout, including in color, including in the strength, and also their mixing proportions also. And it must be of about a fluidity during the transportation period. Definitely, if our site is located too far from the RMC plant, so during transportation also, the concrete should maintain the fluidity, so it should not get set in the transit mixer itself. It should have some flow property, definitely. Wherever we have done the reinforcement structure work, like example, if we cast the slab, the concrete should have a flow ability to pass through the reinforcement also. It must have an ability to be fully compacted, that is without segregation. Definitely the concrete what we are going to pouring into the slab or else any type of structure, it should be of about a taking full compaction. That means when we added the vibrator, it should get fully compacted without having any segregation. It must be of about capable of finishing properly. Definitely the concrete, we can made it into the any suitable shape and size. Even though also if we make us some work on it, so it should give the smooth top surface or else roughened top surface. Like that, it should have a good finishing property also. Okay, what is the properties of this plastic concrete? I told you that the plastic concrete is nothing but like a green concrete or else of about a wet concrete. Then what is the properties? It should have a good workability in nature, and it should not have any segregation during placing the concrete, and it should not possess any bleeding in it, and it should have very good consistency in nature. It should have a very good mobility and also very good compactability. These are the 6 properties of plastic concrete that we are going to study. Then what is a workability? Workability is defined as ease in which concrete can be easily placed, compacted, and made it into the suitable shapes. Okay, then what are the factors that are going to affect in the workability? First is the water content. See, this water content will affect more. Okay, and also second is the mixed proportion. Of course, the mixed proportion also will affect the workability. Size of the aggregate, then how the sizes will be. So that means generally the flaky or of about a elongated of about concrete, so aggregates will not give the good workability. We have to use the angular shaped or of about spherical shaped aggregate. Shape of the aggregate, that means generally of about a I told you that flaky elongated will not give the any workability of the concrete. The river sand and gravel, that will provide of about a greater workability of the concrete other than the crushed standard aggregate. Next is the texture of the aggregate. Of course, the rough texture aggregate will show of about a poor workability, and only the smooth or of about a glossy, that a glassy shaped texture aggregate will give the better workability. Next is the grading of aggregate. For the better the grading, the less is the void content and higher will be the workability. Use of admixture. Of course, the admixture will play a vital role in the workability of the concrete. We are using super plasticizers as well as plasticizers for greatly to improve the workability of the concrete. Then how we are going to measuring the workability of the concrete? First is the slump cone test. Okay, the slump test is of about a widely used method to determine the workability of the concrete. Second is the compaction factor test. That also we can use it for the measuring the workability of the concrete. These testers we can stop in so laboratory. And the third is the VB consistometer test. Okay, this VB consistometer test also we are going to perform in the laboratory, and also the flow test. Let's see one by one. What do you mean by the workability that slump cone test? Have you seen in the picture, there is a slump cone of bottom diameter 20 centimeter dia and the top is of about a 10 centimeter dia with an height of about a 30 centimeter. Okay, so it provides of about a one tamping rod that is called as a 16 mm dia in that and 0.6 meter in length with a bullet end is one end. Then how this test is going to be performed and how the we determine the workability of the concrete at site. Let's see one by one. The test procedure is that first is the internal surface of the conical shape mold is to be cleaned thoroughly. Then once the cleaning has been done, place the mold on the smooth and also horizontal leveled surface. Once it is to be done, the mold is filled with the already mixed concrete with a layer of about 4 layers, and each layer you have to tap with a 25 times with the help of the tapping rod. Once the tapping rod has been done, the top layer of the concrete is stuck off level with the help of the tapping rod only. Generally, at site, we were using the trowel, but we are just strictly as per the IS code says that we had to use only the tapping rod. After that, leveling the surface, the mold is to be removed by lifting it slowly and carefully in a vertical direction to allow to them to the subside. The difference between the height of mold and the highest point of subside, we will measure it as a workability measure. The slump we are always measured in the only, that is millimeter. Then how that after removing the slump, so how the subside the concrete surface will be. See, we are seeing that three different types of slump. One is the true slump. So that means the highest point of the slump to the subside top level will be the slump. That is a true slump. And sometimes the concrete may going to be shear off. So that is called as a shear type of slump. And as soon as we remove the slump cone, if it is fully collapsed, that is called as a collapsible slump. Then there are certain recommended slump which is to be present in it as per the IS code. Let's see one by one. For the column, we will prefer of about 75 to 125 slump for the structure. If it is a beam or a slab concrete, so general slump is required is of about 30 to 125 This is based on the design criteria. For the footings and of about certain retaining wall or else water retaining wall structures, we are getting the slump of 50 to 100 If it is any mass concrete or else of about certain pavement of road work or bridges work, we are getting the slump of about 25 to 50 Next is the second test. We are call it as a compaction factor test. See, for determining the workability of the concrete, so it is very much suitable concrete, but where we going to be used means it is going to be used where the concrete has a very low workability. Okay, where the concrete has very low workability. See, in this picture, you can see there are three different hoppers, that is cylindrical cone shaped hoppers. Name it as A and also the B. And the bottom portion C is abbreviated as a cylinder. In between that, every hopper and the bottom, there is a clamp. That means there is a gate has been given. Let's see the testing procedure one by one. Yes. First is the hopper A. It is filled up with a concrete mix up to the top. Then we have to by operating the trapdoor, which is provided bottom of the hopper A or allowed to be fall on the hopper B. Now, by opening the trapdoor of about hopper B, concrete is then allowed to fall on the cylinder C. Once the concrete thus received has been compacted by a standard amount of work that due to the fall from the hopper to hopper. Concrete in the cylinder has get flushed with the top of the cylinder. Now we have to weight the cylinder is called it as a W. Now the same concrete mix has been poured in layer that is of about 6 layers in cylinder and compact it of about 25 times, taken weight in the cylinder that is called W. Now the compaction is that weight of partially compacted concrete that is W dash divided by the weight of fully compacted concrete that is W is a compaction factor. This is the test as we are conducting in the laboratory. Then IS also recommend, so there are certain values of compaction values will determine the workability of the concrete. Generally, for the low workability, we are getting a slump value of about 0.85. If we getting a slump value of about 0.92, it is of about concrete has a medium workability. If the concrete has got a workability of 0.95, it is a good workability. If it is greater than 0.95, it call it as a very high workability. Let's see the workability in that VB consistometer test. This test is more suitable for the stiff concrete, that is called it as a plastic or else green concrete mix of low and very low workability of the concrete. It consists of about one vibrating table that is resting on the elastic supports, cylindrical metal pot, sheet metal cone, that is top dia is of around 100 mm, bottom dia is 200 mm, and the height is of about 300 mm. In tamping rod, we are using of about a 20 mm dia and of about 500 mm long is fixed on the swell arm, the end of the graduated arm. So, and also it has got one transparent glass disc also that has to be attached from the top to see that how the mixing is going on. The test procedure is like that. Place the slump cone inside the cylindrical part and perform the slump cone test and remove the slump cone. Like however we are doing in a slump cone test by in 3-layer, like that the same thing we have to perform it here also. Once it has been done, remove the slump cone. After that, removing the slump cone, the mold in the glass has to be turned and placed over the concrete mass. Now we have to switch on the controlled vibration as started through the electric vibrator, and simultaneously had to switch on the stopwatch. Allow the concrete to spread it out on the pot. Once continue the vibration till the conical shape of the concrete turns into the horizontal surface that has we have to view from the glass disc, then stop the watch, switch it off and note down the timings. That means the time required for complete remolding of the concrete, that is from the conical shape to cylindrical shape in seconds, is the VB second. Next is that, so let's see, in this test, it is more suitable for the flowing concrete or else of about a concrete having a super plasticizer. Okay, this is a flow test. It consists of about a flow table of about 700 mm by 700 mm with center marking mold and also the slump cone with the tamping rod. Let's see how the workability of the concrete can be determined with the help of the flow test. The test procedure is place the table on a leveled surface and then clean the inner and also the top surface of the table smoothly. The slump cone is has to be placed centrally on the table and it is filled with the concrete of 2 equal layers and tamping lightly of about a 10 times with a wooden tamping bar. The top surface of the mold concrete has to be stuck off and lift up vertically by the handle. The tabletop is then raised vertically up by handles and allowed to fall 15 times in about 15 seconds. The dia of the spread concrete measured in 2 directions, that is parallel to the table edge. The arithmetic mean of 2 dia we will consider it in terms of millimeter. Next is the segregation. Then what do you mean by the segregation? Okay, segregation means the separation of coarse aggregate from the mortar, resulting in their non-uniform distribution of the structure, that means ingredient. Then what is the main causes of segregation? Segregation is due to the improper mix proportion. That means we are using a large proportion of coarse aggregate and smaller proportion of the fine aggregate particle also. In some places, a dropping height of concrete. Generally, that the concrete dropping height should not exceed more than 1.2 meter. And segregation is also can cause due to the over compaction, and also certain places leakage of mortar also takes place through the formwork, that also causes the segregation. When the concrete is mixed in a batching plant is also improper, by the time also it causes the segregation. How do we minimization of the segregation? Yes, the segregation can be minimized by restricting the porite and also ensuring that the proper mixing proportion, that means the mixing ratio will be proper, and also by strict supervision all the concrete operation, that means during the mixing, placing the concrete, compaction also we are going to supervise properly. Next is by proper designing the amount of water during the mixing. This is a vital criteria for the mix design, and for reducing the continuous vibration, that is too much of vibration, definitely it causes the segregation. By adding of about a air entraining agent, that means that also we are going to reduce the quantity of water to be used for the mixing. Then what do you mean by the bleeding of the concrete? It is nothing but the process of rising the water along with the cement particles to the surface of freshly laid concrete. Okay, that is called bleeding of concrete. Then what is the causes and then prevention of the bleeding? That it means the causes of bleeding is excess of water which is present in the concrete. Then when the fine aggregate are of about deficient in the concrete mix, then or else of about to over compaction of the concrete. Then how we are going to prevention of the bleeding? By controlling the water content, or by controlling the compaction, or else by using a finely ground cement, or by adding a pozzolanous powder also. Then what do you mean by the next is the consistence, mobility and compatibility? Let's see that one by one. Consistency is the relative mobility or ability of a freshly mixed concrete to flow, to indicate of about a good workability. Then what do you mean by the mobility? A mobility is the property of a fresh concrete to flow into the formwork around the steel reinforcement without the occurrence of segregation. Then what do you mean by compactability? It is the ease in which concrete can be compacted, or it is an amount of internal work required to produce a complete compaction. Then what are the factors that are going to affect the strength of concrete? First is the water cement ratio. Greater the water cement ratio, of course, gradually lower the compressive strength, and then vice versa. Then is the quality of cement. Finer the grinding of cement, definitely greater the early strength that has to be developed in a cement. Next is the storage of cement. Definitely the storage of cement will play a vital role in the strength of the concrete. That means if the cement has been stored in a godown for a longer period, definitely that will affect the strength of 15% in 3 months, 30% in 6 months, and also reduces the 50% in a year. Next is the moisture in aggregate. Definitely the moisture in sand varies the strength by 20% of its overall. Method of mixing. Generally that the mechanical mixer machine will give the more strength than the site condition. Next is the method of curing. Concrete develops a maximum strength when kept in wet continuously for 28 days. Then is a proportion of concrete substituents. Designed proportion of concrete ingredients improve the strength of the concrete, and the properties of ingredient also improves the concrete strength. Then what do you mean by the compressive and also tensile strength? Compressive means it is the strength of concrete against the crushing due to the direct compressive load. So it can be determined by the casting the cubes or of about a cylindrical shape in the laboratory. Then what are the factors that are going to influence by the compressive strength? First is the water cement ratio. If the quantum of water cement ratio is good, definitely it will increase the strength. Aggregate cement ratio, the proportion of aggregate with respect to cement also improves the strength, and also age of concrete. The fourth is the method of placing, how we are going to place. That means it should not cause us any segregation. And degree of compaction, mode of compaction, either by hand compaction or also about a vibrator. Uniform surface throughout compaction should be happen. Then efficiency of curing, definitely the curing is also major part. Temperature during the curing period. Then what do you mean by tensile strength? It is nothing but the strength of concrete in tension. It can be detected by testing direct flexural and splitting tension. PCC, that means plain cement concrete structure, are not normally designed to resist the direct tension. Tension cracks will develop in concrete due to the diagonal tension.